Hello everyone, welcome to today's lecture. In this lecture we are going to learn about the Ethernet. So let's start. So Ethernet is a communication standard that was developed in the early 80s to network computers and other devices in the local environment such as a home or building. This local environment is defined as a LAN, local area network, and it connects to multiple devices so that they can create, store and share information with others in the location. Ethernet is a wired system that started with using coaxial cable and has successfully progressed to now using a twisted pair copper wiring and a fiber optic wiring. So here Ethernet is a data link layer protocol for transmission. So we are basically using the Ethernet protocol for the local area network, and in the previous time the first cable used, which is a coaxial cable, for the transmission coaxial cable is used, and nowadays this algorithm is used, and this is used on the twisted pair copper wire or fiber optics. Now currently mostly the fiber optic is used, but in the small organization the twisted pair is also used. So in that the Ethernet protocol is used, which is a data link layer protocol, and there are mainly three types of Ethernet protocols, which is a switch Ethernet, fast Ethernet and Gigabit Ethernet. So first is a switched Ethernet. Switch Ethernet gives a dedicated 10 Mbps bandwidth on each of its ports. Suppose we are on there are 5 pieces connected with one LAN. So on that, if it is a switched Ethernet, the maximum bandwidth for that cable is a 10 Mbps. In switch Ethernet, the collision domain is separated. The hub is replaced by a switch, which function as a fast bridge. It can recognize the destination address of the received frame and can forward the frame to the port which the destination station is connected. The switch can receive another frame from another station at the same time and can route this frame to its own final destination. In this case, both physical and logical topologies are star. So in the switched Ethernet, the main thing we need to remember is its speed or its bandwidth, and here the bandwidth is 10 Mbps. The throughput can be further increased on the switch Ethernet by using full duplex technique, which uses separate wire pairs for transmitting and receiving. So if we want to increase the throughput, then we are using a full duplex, and in full duplex both can client and server both can simultaneously communicating with each other, and for that the separate wire is used for sending data and for receiving data. So the throughput is increased, and thus the station can transmit and receive simultaneously. Next is a fast Ethernet. So the 802.3U, the fast Ethernet, as it's commonly known, are approved by the IEEE 802 committee. So the fast Ethernet use the same frame formats, same CSMA/CD protocol and same interface as 802.3, but uses a data transfer rate of 100 Mbps instead of 10 Mbps. So here main thing we need to understand is Ethernet use the same concept of CSMA/CD. Like we are not using the acknowledgement technique, yes, because if we are using the acknowledgement, then much or more collision is increased. So that is why carrier sense multiple access collision detection protocol is used in the Ethernet. And here in the fast Ethernet, the speed is 100 Mbps, while in the switch Ethernet, the speed is a 10 Mbps. However, the fast Ethernet is based entirely on 10 base T because of advantages. Although here technically 10 base 5 or 10 base 2 can be used with a shorter segment length. Here IEEE has designed two categories of fast Ethernet, 100 base X and 100 base T14. So here these are the different versions of Ethernet. 100 base X use a 2-wire interface between a hub and station, while 100 base T4 use a 4-wire. So if the wire is 4, then obviously the capacity or the throughput is also increased and the speed is also increased. So the main functionality is upgrade the data rate to 100 Mbps, make it compatible with the standard Ethernet, use the same 48-bit address, and use the same frame format. Here the version of fast Ethernet is 100 bits T4, TX and FX. The cable used is a twisted pair and fiber optics, and here are some advantages. Next is a Gigabit Ethernet. So the technology is based on the fiber optics cable. Nowadays the fiber optic cable is mostly used, and the Ethernet the fiber optic cable is a Gigabit Ethernet. Multi-mode fiber is able to transmit at gigabit rate at least 580 meters, and with a single mode run exceeding 3 kilometers. So fiber optic cable is costly. In order to reduce the cost of cabling, the H02.3Z working group also proposed the use of twisted pair or coaxial cable for distance up to 30 meters. At giga speed, two stations 200 meters apart will not detect the collisions when both simultaneously send 64-byte frames. This inability to detect collision leads to network instability. A mechanism known as a carrier extension has been proposed for frame shorter than 512 bytes. So in this, suppose because optical fiber is used, so for the short distance it is very costly. So for that we are using the coaxial cable or the twisted pair cable. So it upgrades the speed rate is 1 Gbps. So it is very fast. Make it compatible with the standard or the fast Ethernet. 48-bit address is used, and the same Ethernet frame format is used, and keep the minimum and maximum frame length. Now let's understand what is the frame structure or the frame format of Ethernet. And the standard Ethernet is defined by the IEEE 802.3. So this is the Ethernet frame structure. So it has different parameters like preamble, start frame delimiter, destination address, source address, length, data, and frame check sequence, which is a CRC. Here these two, the preamble and start frame delimiters, are the two parameters which indicates users that your data is coming. Suppose we are on the channel, and at any time we can receive the data. So rather than receiving the actual data directly, we are adding some static data before the data bits, so that this fixed static data we have received. So we can easily find that the data is received to your station, and some alert is given to you by using the preamble or the start frame delimiter. And these two parameter is provided at the physical layer, and at the data link layer the destination address, source address, length, data, and CRC is used. CRC is used for the error checking, and the main are the destination address, source address, length of the frame, and the data. Here the total length of the data frame is 64 to 1518 bytes based on the data, because we have minimum limit is 46 bit and we have maximum limit of data bit is 1500. So here this is if data bit is 46, so 46 plus 2 plus 6 plus 6, so it becomes 64. And if it is a 1500, then 1500 plus 2 plus 6 plus 8, then it becomes 1518. So that is how the maximum size of frame is determined. Now let's understand each term in detail. So the first is a preamble. So it is a 7-byte field that contains patterns of alternating zeros and 7-byte field. So at each and every bit there is only this fixed pattern 10101010. So this pattern is repeated till the 7-byte. So this is a static data which we have attached at the beginning of the frame. So the receiver can we can give the alert to the receiver that you are receiving the data. Next is a start frame delimiter. After this, the 1 byte of start delimiter is used. This is also static data, which is a 10 10 10 11. So this is also a static data. In a earlier day, only this start frame delimiter is only used, and then Ethernet is widely used, so this preamble is also added at the beginning of the frame. So the last 2 bits will indicate the end of the start frame. So when it receives, because this all bits are 10 10 10, and when it receiver receives that 11, then he finds that after this 11 the actual data is started. So 11 indicates the end of the start frame delimiter and marks the beginning of the frame. Now third is a destination address. Destination address is a address of the destination in which we want to send the data, but we are using the hope to delivery. Suppose this is a A and this is a B, and A wants to send data to B, and there are 2 routers here. So here the source, and the next term is a source address. The source address is the address of A, because A want to send the data, and the address is a MAC address of A. And now when it send data to here, then one parameter is used, which is a destination address. So destination address is the next hope address that I want to send data. Then what is the next router I want to use? So that address of next router is the destination address. When data reaches to this router, then it finds the destination address to this second router, and when it reaches to the second router, then the destination address is of destination address of B. So this is how the address is used, and the destination and the source address is the MAC address. And here we are using only the IP addresses in the router. So by using the ARP protocol, we are retrieving the MAC address of each and every router. Next is the length of the frame. So it is a 2 byte field which specifies the length of the data field. This is a required field because Ethernet is a variable size frame, so we need to mention the size of the frame. Next is the data, the actual data, how many bytes we can send. So it is a variable length field which contains the actual data. It is also called the payload field. The length of this field is range from 46 to 1500. 46 is the minimum and 1500 is the maximum. In between we can use any size. Thus in Ethernet frame, minimum data has a 46 bytes and maximum data can be 1500 bytes. And the last is the CRC, which is a cyclic redundancy check field, and we are using this field for the error detection that we already seen in our. So in CRC, how CRC work is we have already learned in our previous lecture. So this is the each and every field of Ethernet frame format. Now next is the advantages and disadvantages of using Ethernet. So advantages is simple, easy to implement, maintenance is easy, and it is cheap. And the limitation is cannot used for the real-time application. Real-time application requires the delivery of data with some time limit. Ethernet is not reliable, of high probability of collisions. High numbers of collisions may cause a delay in delivering the data to its destination. So there are some advanced concept is also implemented, but Ethernet is also used nowadays. So that is all about the Ethernet. Thank you so much for listening.